We're still in 6.8b, and let's just do two more examples. So here I have already drawn the boundary lines for each inequality. We just have to decide what side to color and to say, is the line solid or dashed? So I made all of these dashed, but some of them should be solid, so let's check. So the first one, because there's no equal sign, it should be dashed. The second one has an equal sign, so it should be solid. So let's make the second one solid, the blue one. There, it's solid. Okay, so the first one, we can choose 0, 0 to test both sides for both lines, or both inequalities, because these lines don't go through 0, 0. So let's check the first one. We're going to put 0, 0 into this one. So let's read it this way. 0 is bigger, no, 3 is bigger than 0. 3 is bigger than 0. 3 is bigger than 0. Yeah, 3 is bigger than 0, that's true. Okay, so that means this side of the line 1 is true. So any point from, let's cover this. So I'm looking at line 1. So any point from this side, if I take any point and I substitute it into inequality number 1, it will make this inequality true. So we have to color this side of the first one. Now let's do the second one. Now because this blue line does not go through the origin, I can pick that easy point again. I'm going to go, let's put 0, 0 into this inequality, the second one. That's 0. So now we say 0 is bigger than or equal to 3. Is 0 bigger than 3? 0 bigger than 3? 0 bigger than 3? That's false. Okay, 0 is not bigger than 3. So I'm going to look at the second boundary line here, and this point is false. Okay, that means every point from this side of the boundary line is false. That means everything on the other side is true. So I have to shade the other side. Now I have to go, okay, what area has been shaded twice? And I can see here, here, all of this area has been shaded twice. So this is my solution set, because that area has been shaded twice. Now let's do another one. Let's do number 3. So first let's see if the lines are dashed or solid. So the first inequality has an equal sign, so I know it has to be solid. So number 1, the red one, is solid. So let's make it solid. Oops, I should use a ruler. There, let's erase the messiness from here. That's a solid line. And the second one, there's no equal sign, so we know it's dashed, so we're just going to keep it the same. Okay? So now we're going to look at equation number 1. Let's pick an easy point, 0, 0. And substitute it into here to check to see if it makes a true or false statement. I'm going to substitute that into this. Two times 0, 0, so there's just 3 here. So this says 0 is bigger than 3. 0 is bigger than or equal to 3. 0 is bigger than 3. Is 0 bigger than 3? Nah, that's false. So I'm looking at line number 1 right here, and if I substitute this point into the inequality, which was 0, 0, it's false. So everything on this side is false. That means everything on this side is true, and we always color the true side. There. Now let's look at inequality number 2. Well, I can't pick 0, 0 because it's actually on that line. So what I'm going to do is I'm going to pick another easy point So I'm going to pick something on the y-axis or the x-axis, because then I still have a 0, because zeros make things nice. So this is 0, 1. Okay, so I'm just going to choose this point. I could choose any point I want, but I'm going to choose 0, 1. I'm going to substitute 0, 1 into that point. So that's x, that's y. So y is 1, so put a 1 here. 1/2 x is 0. What's half times 0? 0. So this says, if I read it this way, 1 is bigger than 0. 1 is bigger than 0. 1 is bigger than 0. Yeah, 1 is bigger than 0. That's true. Okay? So when I look at this blue line, number 2, here's my blue line. When I substituted this point into the inequality, it was true. That means everything on this side of the inequality is true. So I'm going to shade this side of the line. Now I have to go, what area has been shaded twice? So I can see this area has been shaded twice, so this is my solution set here. This part here. Okay, so that means if I take any point from here and substitute it into these two inequalities, both of them will be true statements.